Okay, we're doing Tech Math 3 Pre-Calculus Combined class. We are currently in section 10-3 and we're concerned about radians. So if I have a circle, let's see if I can find a circle. So if I have a circle, then that circle has a radius, r. If I take that radius, r, and wrap it around the circle, so that now my r comes around the circle, then I got some angle right there, theta, and we say that theta is going to be 1 radian. Okay, well, we're going to do it again. So I have this circle, and I have this circle, and might as well have 3 of them, right? Would have been a good idea to pick the same center, but that's pretty good. So now I got a radius of this guy going to there. I wrap around to here. I got a radius of the second guy that goes to there. I wrap it around to there. I got a radius of the third guy, goes out to there. It gets wrapped around to here. And then I see where my 1 radian is. And so 1 radian doesn't matter how big the circle is. It's the same angle, theta. I forget who told us this. I think it was before Newton maybe, but it's hard to say. Now, in my Calculus 1 class, I was at Michigan State, and the vice chairman of the math department was teaching my calculus class. Now, Michigan State has 500 math instructors. So the vice chairman, important, right?
Yeah.
Anyway, so he has 2 proofs that radians exist. No, he has 2 proofs that sines and cosines exist. A simple proof that'll take a half hour, and a more rigorous proof that'll take 3 days. Okay, so he's got a half-hour proof and a 3-day proof. He decides on the 3-day proof because in the simple proof they use radians. Now, can you have a radian without having a sine or cosine?
Let's say.
Da, 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 da,
Come on, guys, say something.
yeah. So it turns out that if you have a radian, you also have to have it's automatically assumed that sines and cosines exist if you have a radian. So if you do a proof that cosines and sines exist, and in the proof you include a radian, then you're host. Okay. So anyway, day 2.5 of the proof, he throws in a radian, he throws his chalk down on the ground, walks out of the room.
Wait, was it?
He doesn't have a proof. He doesn't have a proof that sine and cosining. Now, do sine and cosines exist?
Well, they're on the calculator. So
Yeah. So we don't really care, right? So you have to be a mathematician to care that there's a proof to prove it, you know. So anyway, that's just the way it was. All right, back to what we're doing. If I have 2 pi radians, if that's the case, what's the circumference of a circle? Pi d, right? 2 pi r. So if I have 2 pi radians, I have 360 degrees. If I have pi radians, I have 180 degrees. So now if I have 1.734 radians. Okay, ready? 1,000. Okay, you got it?
Okay, go back up for 22 seconds.
22 seconds.
Lord knows I got to keep track of time. 19.
All right, 22 seconds, all that.
All
Okay,
right.
so if I have 1.73 radians, and I want to know how many degrees I am, and I have an older TI-36 other than this brand new guy, then I just put it in my calculator and it'll tell me. Okay, the new guy won't do that anymore. He doesn't have a conversion radians to gradients
Why not?
to I don't know, but the old guy did. So anyway, I know that if I have pi radians, I have 180 degrees. So if I have 1.734 radians, how many degrees I have. So that's what I'm going to do. I'm going to do a simple ratio thing and say, well, how many degrees do I have? Number of degrees unknown is going to be cross multiply 180 times 1.734 divided by pi. And now all those things are in my calculator. 180 times 1.734 divided by pi. So I get 99.35 degrees. And now the issue is, how many significant digits do I have? Does a 4 significant digits in radians convert to 4 significant digits in degrees? And I'm sure the author tells us that someplace, so we'll just leave it that way. But that's what I would do. Now, pi has an infinite number of significant digits. I don't have to worry about it. How many significant digits in 180? The same infinite number as I did in pi, so that's not an issue either. So the only issue is the other guy. So let's go the other way. I got 34.973 degrees, and I want to know how many radians that is. Okay, so pi radians is 180 is equal to some question mark of radians is 34.973. So my question mark of radians, 349.973 divided by 180 times pi. Now it's time to put it in my, it may have been time to put in my calculator before then, right? But it's definitely time now. 43.9 divided by that times something else. Zero point. Say I got 5 significant digits. 0.61039. 39 radians. Isn't that lovely? Now, when we get to chapter 28, we find that the sine of sine of x is x minus x cubed over 3 factorial plus x to the 5th over 5 factorial minus x to the 7th over 7 factorial plus blah 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 blah. Now, if I put in x here, if I try to find the sine of 90 degrees, I'll get the wrong answer, because this particular expansion has to have radians. So how many radians are there in 90? So this would be the sine of pi over 2. So the sine of pi over 2, and then I could put those x's could be pi over 2, and then I'd get the right answer. So when I take my calculator and I go 35.27 sine and find the sine function, what my calculator physically does is change the degrees into radians, put the radians into that particular formula with probably 10 terms in it, and then shows it up on this calculator before I take my finger off the enter key. That's what it does. So there's no lookup table in my calculator to look it up. I calculate the sine, I calculate the cosine. I have another formula that will calculate cosine. Cosine x 1 minus x squared over 2 factorial plus x to the 4th 4 factorial minus x to the 6th over 6 factorial plus blah 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 blah. Now, what we haven't discussed are functions that are odd and functions that are even. I don't think we discussed that. So if I have an even function then f of x is equal to f of minus x. If I have an odd function, then f of x is going to be equal to minus f of minus x. Now, when I look at the cosine function, I see that all the terms are even, right? If I square, or I take the 4th power, the 6th power, or the 2,956 power of something that's odd, I get an even number, right? If I look at the sine function, all the terms is odd. So part of that definition, where we get our definition of even and odd, comes from these series approximations, where in fact the series approximation is even and odd. Okay, so that it wraps the circular logic wraps around back upon itself at that point. Is that all there is? No, I guess there's something else. There could be something else. It's hard to say. So now, when I look at the sine, the cosine, the tangent, the cosecant, the secant, and the cotangent, I ran out of room. I'm not going to think of them as the answers in terms of degrees anymore. I'm going to think of it in terms of radians. Okay, so I got 0 radians. Cosine, sine is 0, cosine is 1, tangent is 0, cosecant is undefined, secant is 1, cotangent is undefined. Then I think of 30 degrees, pi over 6. 6 goes into 180 30 times, radians. And I think about 1/2, and I think about the square root of 3 over 2, and I think about this, what do I think about? 60, what's the square root of 3 over 3? Square root of 3 over 3, and this guy's going to be 2. This guy's going to be 2 the square root of 3 over 3, and cotangent. Quick, look, what does it say? Cotangent is square root of 3. I knew that. Square root of 3. And then I think of 45 degrees, pi over 4, would be 45 degrees, and this guy's going to be square root of 2 over 2, square root of 2 over 2, 1, 2 the square root of, is that just the square root of 2? 1 over that guy, 2, oh, that was convenient. Totally convenient there. I wonder how many more times I can do that. Okay, so I got 2 over the square root of 2. So that would be 2 to the square root of 2. 2 to the square, no, just the square root of 2. Anyway, what does the book say? Anybody look? Yeah, square root of 2. Okay, finally. Well, that's got to be the square root of 2 too, right? Square root of 2. And cotangent's going to be 1. And then I do the same thing at 60 degrees. 60 degrees, pi over 3. Pi over 3, yeah. And then 90 degrees, pi over 2. So now I may have had that table of what my sines and cosines and tangents was memorized in degrees. Now I get to do it again in sines and cosines. Now, Now look at this very first line here. I'm going to do it over again. Maybe if I get down here. I'm going to take the sine of theta, and I'm going to look at pi over 6, pi over 4, pi over 3, pi over 2. And I'm going to remember that that's 30, 45, 60, and 90 degrees, but I'm not going to write it down. And then I'm going to write 0 over the square root of 4. 1 over the square root of 4. 2 over the square root of 4. That's wrong. Okay, I got it. The square root of 0, there we go, now I got it. The square root of 3 over the square root of 4, and the square root of 4 over the square root of 4. So this is a memory aid for 30, 45, 60, and 90 degrees. And then what's 0 over something? Well, that's 0. What's 1 over the square root of 4? That's 1/2. This is the square root of 2 over 2. This is the, shit, what happened? Anybody have their act together out there at all? Anyway, back to what I was doing. There's a 0 sitting here. That guy goes to 0. That guy goes there. This guy goes over here. All right, now I'm all set. 0, square root of 1. So that'd be 1/2. 1/2 square root of 2 over 2, square root of 3 over 2, square root of, no, that'd be square root of 4 over the square root of 4 is 1. Okay, so so you're going to forget the memory aid right away? Yeah. Anyway, so there is a memory aid. And then if I'm doing cosine, it goes the other way. So there's 0, 30, 45, 60, 90 if I'm doing cosine. And when I'm doing tangent, I just go tangent is sine over cosine. And now that I already know sine and cosine, I can find sine over cosine. And I'm all done there. Okay. Any questions? Other than why is the instructor mumbling?
No.
Anything other than that? Okay, good. All right, so we'll work some problems. All right, we'll do 4. And number 4, we have 270 degrees, and we want to know radians. 3/2 radians, 3/2 pi radians. Okay, I did in my head. All right, so that doesn't count. So pi radians is 180 degrees. How many radians are there in 270 degrees? All right, so I got 270 divided by 180 pi radians. And when we talk about radians, we normally leave the pi. We don't get rid of the pi. We like pi. Pi is wonderful.
Yum.
Yeah. Very yummy thing. And 90 goes into the top guy 3 times, and the bottom guy twice, 2 times. That's how I got that. No, it's not. What I did is I'm looking at a unit circle. 0, pi over 2, pi. Well, if this is pi over 2 and that's pi, I'm going to have to add another half pi. What's a half plus 1? 3 pi over 2, 2 pi. So as I go around the unit circle, that's what's happening. And so that's how I did it. I didn't do this. I did that in my head sometime. Okay, number 8. I have 2,490 degrees, and I want to change that to radians. Well, isn't that just hunky?
Yes.
Yeah, just totally wonderful. Well, I think I'm going to take 2,490, and I'm going to divide that by 360. And I'm going to have 6.916 repeating. That's what I'm going to do. So that's how many 360s I got. I'm going to subtract 6 from that so that I only have the 0.916 repeating left over. And I'm going to multiply it by 360, and I'm going to get 330 degrees. So when I subtract all the 360s that I have going around, I only have 330 degrees. All right, so I look at my unit circle. When I make it to here, that's 3 pi over 2. When I make it this way, that's another pi over 3. It's another 60 degrees I have to add on, right? So 2 pi over 3 pi. 3 pi over 2 plus pi over 3. That's a plus sign in case the Mundo wants to know. Okay, now, so my common denominator is 6. So I got 9 pi over 6 plus 2 pi over 6. So it's 11 pi over 6. So that'd be my last answer. Okay, well, I don't... is that the real answer, though? That's probably not good enough. We probably have to add back to that 6 times the 2 pi I took away, right? So if I add, so I'd have 6 and 11 6 pi radians. There we go. Now I'm done. Well, that was a pain. Why would I want to do that for? Okay, so I'll do it a different way. 2490 degrees. We want to know in radians, knowing that 180 of them is pi radians. 2490 pi divided by 180 equals what? 2490 divided by 180, 13.833. What's 0.833 anyway? No, it's not that. 0.833. Okay, that's 5 6 pi radians. 13.83 repeating would also be perfectly okay. And you could multiply the pi through if you wanted to, and I'd have to accept that too, because I'm that type of guy. Okay, we'll do number 10 next. Number 10. Oh, that's a good question. 21 more minutes? No.
They don't really mean 21
No,
minutes.
it's going to give me a warning with 5 minutes to go, right? Wrong one. All right. Stupid calculator. I don't know which is worse, the calculator or the All right, good call from the front row there. Can you actually see it down there?
Yeah.
That's amazing. I couldn't see it where I was sitting. All right, so I've got 7 pi over 6. So I've got a pi plus a pi over 6. The pi is 180. The pi over 6 is 30. So this better be 210. Okay, so I could do that. Or I could say 7 pi over 6 is the sum question mark of degrees, as 180 is to, not 180, 1 pi radians is to 180. And then I could go 7, 6 times 180 is 210 and get my final answer that way. I could do that. So I could go either way. Number 16. Got 1.82 radians, and I want to send that to degrees. Okay, so pi is to 180 as 1.82 is to some question mark degrees. Cross multiply, question mark degrees is equal to 1.82 times 180. How come that doesn't look like 180 over there? Divided by pi. Does that look better? And in this case, we want to get rid of the pi. 1.82 times 180 divided by pi. 104 degrees. All right. All right, we'll do 22. We've got 17 pi over 12, and we want to find the reference angle in degrees. Okay, so 17 pi over 12, that's something that's bigger than pi, but less than 2 pi, and it's less than 3/2 pi, because that'd be 18 over 12, right? So this is a third quadrant guy. In the third quadrant, my angle is equal to 180 plus the reference angle. But I want to do the problem in radians. So my angle is going to be equal to pi plus the reference angle. And so the angle is 17 over 12 pi. Okay, so my reference angle, 17 over 12 pi minus, that's a pi in case anybody was wondering, 12 over 12 pi is 5 over 12 pi. So that's how I would do reference angles and stay in radians. Would I remember reference angles in radians formulas? No, I wouldn't. I remember it in degrees, shift it to radians if I needed to. Okay, 26. The cosine of 7 pi over 6. Now, I could change 7 pi over 6 to degrees and find its cosine, right? I could do that. Or I could take my calculator, go to mode, and change it to radians. So now my calculator is in radians. Second function I'm going to quit. And now I'm going to say cosine of 7 times pi divided by 6, close parentheses, equals. And I end up with 0.866 with a negative sign in front of it, which would be perfectly okay. Now, if I look at this again, I see that that's has a reference angle of the cosine of pi over 6, which is the square root of 3 over 2. And in the second quadrant, this is going to be negative, so the square root of 3 over 2 with a negative sign would be right. So if your calculator was inexact, that's what it gave you, right? Minus the square root of 3 over 2. Perfectly okay, unless it says 4 significant digits or something silly like that. All right, we'll do 34. Number 34. The tangent of theta is minus 1, and I'm going between 0 and 2 pi. And I want my theta to be in radians. Well, I can want all I want, but okay. So anyway, I got my tangent curve. It looks something like this. That is pi over 2. And over here I've got pi. And right there I've got 3 pi over 2. And right here I have 2 pi. So if I go to -1, that's going to be there. And I'm going to have an answer here and an answer there, which is a second quadrant answer and a fourth quadrant answer. All right, well, that could very well be. Okay, so theta is equal to square root of 2 over 2. And in the second quadrant, it's going to be negative. And in the fourth quadrant, it's also going to be negative square root of 2 over 2. That's so messed up.
Yeah.
I mean talk about loss of control, loss of everything. I mean, that's just so messed up. I just can't believe it. All right. Well, the reference angle for -1 is going to be 45 degrees. So this is going to be pi over 4. So this is going to be 3 pi over 4. That guy is going to be 7 pi over 4. There we go. Now I'm better. If the picture was better, the whole thing would be better. No, but now I'm better. So if I was doing it in degrees, I would know that the tangent of 45 is 1. The tangent of what? 225? 125? 135. 135 is -1. So 135 degrees, that's 3 pi divided by 4. All right, enough of that. Find the value of each trig function to 4 significant digits. Okay, we can do that. Number 54. The sine minus pi over 6. Oh, we can do this one in our head, but we're not gonna. My calculator is in 54. Right, so I've got it in my calculator. Sine. Where's my sine function? Sine minus 5 times pi divided by 6. Boom. A half. That would have been my guess. Minus a half. All right, one last problem and we'll go away. 66. Huh? What? I don't have enough significant digits? Oh, darn. Minus 0.5000. You're right. I got that one wrong.
That's what it says.
That's what it says. It said 4 significant digits. That's what we have to have. I agree completely. In the reduced light in the front of the room where I sit, I can barely read the book as it is. 66. Cotangent is minus 0.1066. And we want to go between 0 and 2 pi. So we're going to get 2 answers between 0 and 2 pi. That's what we're looking for. Okay, my calculator is still in radians. I'm going to go 1 over the cotangent of theta is equal to the tangent of theta, which is going to be 1 over that number. 1 divided by 0.10666. Boom. minus 9.380863. Okay. Then I'm going to take the arc tangent, might look like that on your calculator, arc tangent of that guy. Okay, so I'm going to take the arc tangent of that guy, arc tangent of the answer, arc tangent of minus the answer, because I didn't take my minus sign with me. Okay, so I got minus 1.46. How many significant digits? 4. 464 radians. Okay, now I need, so that's what theta is. Theta equals that. Now my arc tangent function goes through 0, goes to infinity, goes like, well, that was really professional looking. Looks something like this. Okay, and this happens at pi. That happens at pi over 2. This happens at 3 pi over 2. That happens at 2 pi. All right, now, if I'm minus 1.46 whatever radians, how am I going to get out of that? All right, so I'm going to come up with a reference angle. This is obviously a fourth quadrant answer, right? That's a fourth quadrant answer. So I'm going to also want a second quadrant answer. So I'm going to look for a reference angle. So my angle in the fourth quadrant is 2 pi minus the reference angle. No, it's reference angle minus 2 pi. Reference angle minus 2 pi. Minus 1.46 radians. I don't know what quadrant I'm in. We're going to have to shift 1.464 radians to degrees. So 1.4, we'll do it on the side over here. So pi divided by 180 is equal to minus 1.464 divided by some number of degrees. So I'm going to go my answer times 180 divided by pi. Okay, so I'm at minus 83.91 degrees. So that means I do have a fourth quadrant answer. I'm going to add this guy. I'm going to take that guy and I'm going to add 2 pi to it to find the fourth quadrant answer. Okay, so I've got 2 times pi minus 1.464. Okay, so theta is going to be 4.819, and that's going to be in the fourth quadrant. Okay, now I need to find a second quadrant answer before I can go home, or I die of old age, whichever comes first. Alright, so that's the fourth quadrant answer. I want the reference angle. So 4.819 is equal to 2 pi minus the reference angle. So, and the reference angle is my first quadrant answer. So that's a first quadrant answer. Okay, that's going to go there. So 2 times pi minus 4.819. So we've got 1.464. I should have known that. Okay, so that's my reference angle. Now I want to find the second quadrant answer. So in the second quadrant, the angle is going to be pi minus the reference angle. So pi minus 1.464. Pi minus the answer 1.677. All right, so I got two answers, 1.677 and 4.819. We're going to check it. We're doing 66. All right, so I'm going to take what happened. Huh?
No, he moved the mouse over the corner.
Oh. Something happened. I don't know what it was. So if I take the tangent, if I take 1 over, 1 divided by the tangent of 4.819, I better get minus 0.1066. And I do. And if I take 1 divided by the tangent of 1.677, I should get the same thing. Okay, excellent. I checked my work, it's right. Any questions? Is it time to go home yet?